Hello and welcome to Herding Code. This episode is being recorded on March 11, 2022. Today I'm talking to Bruno and Mark, and they're going to teach me all about Java because I don't know a thing about it. So welcome, folks.
Hey, John, how's it going? Thanks for having us.
Good. Yeah. So can you introduce yourselves? Tell us your background.
Yeah, I said something. I'll let Mark go first. Go, Mark.
Hi, I'm Mark Heckler. I'm a Java developer for, a long time now. Java champion, Kotlin developer expert. We won't talk about that too much today, but deep in the JVM and loving it and still loving it. So, and I work, I guess, on an aside, I work in developer relations here at Microsoft, engineering, cloud advocate for Java and JVM languages.
Cool.
All right.
All right. And Bruno?
Yeah, I'm a PM manager at Microsoft. I lead some of the projects on the PM side, like Microsoft Deployable in JDK, and Microsoft's involvement in the Java community, like our work with the Eclipse Foundation, Java community process. I am also a Java champion. And for those who don't know, Java champion is a program similar to Microsoft MVP, but for Java developers. And yeah, it's been my career for a long time, too long, I would say. But I have something in common with you, John. My very first professional job was a Delphi developer.
Oh, wow. Okay.
Yep, for a month.
Okay.
If we're coming clean, I have actually done some Visual C++ and Visual Basic back in the day as well, but that's been a long time ago, and I and I'm recovered. So
I got my start. My first professional job was Visual Basic, and I was chatting with someone about this recently. One of my things there was like I was doing VB, and then we got this offer for a job in C++, and I kind of bluffed my way into it. I was like, hey boss, I think we can do this. And right starting that project, I found tons of Y2K bugs, and it was September of 1999. So I like signed myself up for all kinds of trouble.
So. And you're thinking, why did I do that?
Exactly. Okay, well, let me start off with just one thing, which is like so Microsoft Java, how does that fit together? Like, why is that a thing?
That is a thing in the past 5 to 10 years because of cloud computing, right? Developers want to bring stuff to the cloud. Microsoft became a cloud vendor. Microsoft hosts any kind of application, and that includes Java applications, right? But it's also through the history of Microsoft, and I don't want to go back in time too much because some experienced Java developers will remind a few things. But in more recent times in the history, Microsoft did welcome some companies and came up with some solutions that ended up either being developed in Java or using Java-based technologies. So the big data exploded about a decade ago, and in projects like Apache, Spark, and Hadoop that are implemented in Java ended up being used by every major company, including Microsoft. So those systems are in use internally, whether it's Microsoft Bing service or Office or Azure infrastructure behind the scenes. We see those Java-based technologies in use. Apache Kafka more recently. So Java and the Java ecosystem and tools are needed for scalable systems, and that happens to Microsoft as well. And then Microsoft also welcomed LinkedIn and Mojang, Minecraft, and those are technologies that are heavily implemented in Java with thousands of Java developers that now work here in the company. So not only Java is a matter of like we use the technology, but we also, of course, offer our tools and services to the customers outside. And the way that they host their applications is through Azure at the end of the day.
Okay. Yeah, I was going to say that my main exposure to Java over the past several years, thinking about it, has been helping my kid with Minecraft. Like, and she wants to install all the mods and all that kind of stuff. So,
Yeah,
um,
and the interesting thing is Minecraft today, if you're playing with Minecraft Java Edition, the binary of Java that is shipped with Minecraft is actually a binary that we build ourselves, the Microsoft build of OpenJDK. And if players and developers are in sync with their release, they will see that Minecraft is running on Java 16 already, if not 17. If I'm not sure if the Mojang team already updated to Java 17, but they did to 16 at the end of last year. So it's pretty modern, pretty up to date with the Java release history.
okay. So you mentioned OpenJDK, and what's the ecosystem like now as far as like who's developing Java?
Primarily, who develops Java is still Oracle. Oracle is the steward of the technology and the platform, is the steward of the OpenJDK project. And OpenJDK is the open source implementation of the Java platform, which includes the Java language specification, the JVM specification, and the Java APIs. So those three things combined, they form the Java platform. And OpenJDK is the open source implementation, GPL. Um, but there are lots of contributions. Red Hat is a major contributor to the OpenJDK project. IBM, Azure Systems, Bellsoft, Twitter did some contributions. Alibaba, Amazon, Google in the past, and now Microsoft in recent times. Companies that we imagine like they were competitors, but still because they saw this technology as a great piece of software to do several things at scale, they all got together and said, "Hey, let's make something great." And OpenJDK works as a true open source project with very high quality professionals involved and major companies behind supporting its development.
And if I can interject something here, everything in terms of Java kind of builds around and revolves around the Java community process, and that's not just in name. So you have a lot of participants at an individual and corporate and organizational level that kind of come together and help guide, steer, develop specifications, and kind of suss out and test out different technologies as they start getting incorporated into Java, the specifications. So specifications, I should say. So it's very community driven. Oracle kind of serves as the central point and kind of is the force behind continued development. But there are a lot of contributors to that entire process, start to finish.
Yep.
Okay. So let me tell you what I did trying to like get up to speed a little bit with Java, and you can tell me what I should have done instead. I Googled around and I saw Microsoft Java get started, whatever, and I went over to the VS Docs page and I installed, or excuse me, the VS Code page, and I installed the extension, the Java extension pack, and it installed a bunch of extensions. And then I created a new project. Well, first I went on and I downloaded the OpenJDK just to make sure that it was installed in the newest thing and stuff. Um, and then I also played with JHipster a bit just because I'm a web developer and it seemed fun. And I was pretty impressed with all of it. There's the usual kind of trying to figure out what is Maven and what is Gradle and where's my Java home pointed and that sort of stuff. But it was pretty smooth and a couple hours. What do you recommend for people getting started with Java development?
I'll start off with this because that's something that I feel like, and we're certainly not alone in this, but I feel like we could do a better job on getting people that kind of that first experience. You did a lot of good things there. I don't know that I could necessarily suggest improvements, just because there are some rough edges there. I mean, when you're talking about a build tool, if you're not within the Java ecosystem, if you're not within the Java realm, you're like, what's Maven? What's Gradle? VS Code with a small handful of plugins knocks down a lot of those barriers for you. If you install the JDK, that would be something that would be kind of awesome if we had some kind of like drop this in and everything just works. But there are a couple or three steps that you mentioned. I know some folks are very, very fond of REPLs and JShell and et cetera. But ultimately, I think it comes down to just finding some good materials that you can kind of get at that gentle introduction, a step at a time. And it sounds like you're already there. And of course, if you have a frame of reference that you're going from, like you mentioned, Jay Hipster, which, by the way, Julien Dubois, who is my manager, is the lead of that project.
Cool.
So he's a Microsoftian as well, and heavily involved with the community. So that's something that is, if you're coming from a frame of reference, it should be easier to pick up in that regard. But everybody doesn't share the same frames of reference, so that's part of the, I guess, struggle that we're all trying to help solve, help make better.
Yeah, the Java ecosystem can be frightening after you spend an hour reading blogs and articles and try to make some sense out of it. Uh, because it's a very diversified ecosystem. There's no single technology vendor for any component in the Java ecosystem. Oh, I need the JDK, right? That's the basic component you need. There
Yes.
are 7 vendors, right?
Or more, maybe more tomorrow.
Or more. Oh, I need an IDE or editor. Well, there are 5 options out there, right? And then I need a framework to build my application. Well, there are probably too many. And then finally, okay, I selected my JDK, my editor or IDE. I have a framework in mind. I still don't know what that means, but I have something in mind. I made a choice. I don't know if it's the right one, but it's there. And I still need to build that project. So I need a build tool, right? And there are actually more than 2. Maven and Gradle are the most used ones, but there's actually more than 2. There is Apache Ant, Apache Ivy, and Babel, or not Babel, sorry, something
Bruno,
like
I'm going to paraphrase. We don't talk about those, Bruno.
too many. So it can be frightening. But what Mark said, I think it touched. If a person doesn't know anything about Java at all, just go online, search for something that says getting started with Java, and something that does not involve building a web application on the very first step, and then get started with that. Okay, here's my first Java application. Here's my first Hello World application. And if a developer is already familiar with an IDE or editor, try to see if that technology supports Java. And if it does, use that. Once you got a good sense of, here's my Hello World application, I'm reading a file, I'm counting lines in a file, doing some math, get some sense of the language. Then next step is, okay, I actually want to do a web server. I want to get HTTP requests and provide HTTP responses. Then there is, again, a multitude of frameworks that can do that, because that is ultimately the majority of systems that are built today. But just go and get started with anything and then start learning from there. And once you pick a framework and you feel like, oh, this is interesting, this is cool, and your criteria was probably, oh, this is the most used one, or this has the nicest website. I don't know, whatever criteria, right? And try to dive in a little bit on that one to understand concepts, understand what are the features, capabilities. Because the reality is most frameworks can do the same thing. There's a lot of overlap of features. And back to what I said before, it can be frightening because, .NET is awesome because it is open source, but it's also coming from a single company, right? There's no, how many web frameworks are out there for .NET? It's not that, right?
There's a few, but you're right. It's basically there's one.
Yeah, exactly. So that can help for beginners, and developers have to get through that barrier for the Java ecosystem for sure. So follow Mark's advice. Search for something, get started.
Yeah, and I don't want to chase this down this rabbit hole too far, but I mean, you always, what you're familiar with, you always see the pros, and you also see the glaring, I hate to say deficiencies, but you can see the gaps, right? So one of the strengths and weaknesses of Java is exactly what Bruno said. Oh, I need a JDK. I need a version of Java. Well, what version and where do I get it? Which one? Because you have options. And the good news is that means it's open. I mean, you can, if you want to use the Microsoft build of OpenJDK, it will work. If you were using yesterday, if you were using somebody else's, and you swap in this one, and it's like, wow, everything just works, which is amazing. But when you're coming at it fresh and you're new, and you're like, okay, where do I go to get this? Well, pick one. Okay, which one do I pick and why? So it gets a little weird at times. Now, Bruno mentioning the tons of frameworks and stuff. I mean, we're not JavaScript, so there's not a new dozen every day, and 22 of them who die the next day. So
Right.
so I guess there's that. But yeah, it's the same things that make it so flexible, and in many ways make it a little more imposing for somebody coming into the ecosystem new. But I mean, like every ecosystem, we have tools that help with a lot of these things. I couldn't live without SDK Man, so I can choose between various different SDKs just with a simple command at the command line, and then I'm using something else or somebody else's build or a different version or whatever, and it just takes a lot of the pain out of that. But again, if you're new to the ecosystem, you're not aware of that, so then you're manually doing some of the steps that you wouldn't necessarily have to do.
Yeah, Mark mentioned the command line tool called SDK Man, and it's one. Funny enough, it's one of the many tools that you can use to manage JDKs.
Okay.
So there are actually more than one. So there's always, that meme, right? These 14 standards are bad. We need a new one. Now you have 15 standards. Right. It's the same thing in the Java ecosystem. But this goes all the way back to when Java started and Java became open source. Even actually before Java became open source, because the way that Java was offered by some microsystems as a free technology from day one, not necessarily open source, but free for production, allowed developers in the world to build products on top of Java. And that's why lots of libraries came to be. Lots of build tools got created, and frameworks for applications, desktop applications, web applications, and of all kinds. They were born. So that allowed this ecosystem to exist the way it exists today, and it only gets better for whatever definition of better you look for.
15 standards.
Yeah, there you go. Yeah, so like SDK Man, and that makes me think like there's Python has virtual environments, and npm it's got common. Like, is that the idea where you're setting like for this project or this directory, I'm using this SDK?
Yes.
Okay.
Yes, that's the idea. I'm not sure if SDK Man has that capability right now. I would double check. But there are some other projects that allow that. Jamv is another command line tool that does exactly that. I want to say this folder here, I want to use that JDK. So Jamv is a shell script that you configure in your shell, and it will update the JDK based on your current directory automatically. So there is dearenv, which is another generic tool for that, and you can do the same thing for Java with dearenv and other tools.
Okay. Let me see. So then we did talk about like there's Maven and Gradle. Is there like a cliff notes for like, is it just pick one, or is there a significant difference between them?
Oh my goodness. You don't want to get in the middle of that.
Okay.
I want, Mark. I want. So let me get started. Both tools are great. First of all, both tools are great. They will deliver what the developer is looking for if the developer doesn't know what they're looking for. But if they do know what they're looking for, it's either one or the other.
Okay.
So Maven it starts with convention over configuration. You define your build using XML, and it's very descriptive of the things that you want to do using the XML specification of the build file.
Was that the pom.xml file that I? Okay.
Yes, correct. So okay. you can use a variety of plugins that are official plugins maintained in the Apache project, or third-party plugins maintained by other folks outside the Apache Foundation. And then there is Gradle, which is the default on Android Studio. So Android developers that are already coding in Java and now they want to do a server-side application I highly recommend that they use Gradle for that because you're already familiarized with the build tool. And Gradle has some interesting capabilities like a build cache that and a build daemon that is running in the background. So your compilation happens a lot faster whenever you're rebuilding your project. Um, but Gradle is a little bit different the way you configure your build file. It comes with a more like programmatic way of doing things. It uses a language called Groovy, and with that you can write the code with the instructions of how you're going to build. So it's different. If you know how to use it, you go to the documentation, just copy and paste, make it work, and learn along the way. And for XML and Maven, it's more like, yeah, this is the only way of doing it.
Yeah, I'm going to jump in and correct Bruno on some things he got all wrong. No, I'm kidding. No, I'm going to expand on something Bruno said. Bruno's like, what? It's kind of interesting because the two approaches are pretty different. Because Maven is more declarative, and in the era of YAML and Kubernetes and a much more declarative infrastructure as code type of mindset, the Maven mindset fits a lot better in that because it is you literally lay things out in XML as Bruno said, and it's just you're declaring it and then it does the rest. Now Maven is pretty minimal. It's the plugins that really do a lot of the work, which is for a developer is largely irrelevant. You just want to make sure your stuff gets built, right? But Gradle actually uses either Groovy or Kotlin, depending on which script you use, Groovy script, Kotlin script, and Groovy or excuse me, Gradle is, as Bruno mentioned, programmatic. So it's an execution of a program that if you have a very simple build is very clean and very elegant. If you have a very crazy complex build, it can, as Bruno also mentioned, dramatically reduce your build times. But as they say, the devil's in the details. It's a program. So there are ways that it's hard. It's easier to get things wrong. It's easier to mess things up. And in many cases, I hope I don't get anyone mad at me for saying this, but when versions change with Gradle, several times you have folks who have issues, very quick to be resolved and stuff typically. But with Maven, again, being more declarative, you typically don't have a lot of those. So everybody's got a very strong opinion, it appears, either one or the other. So you get this really hard partisan fight. But they're both excellent tools. They both enjoy very wide industry support, and they just work generally. So,
yeah,
Okay.
yeah. If the developer doesn't like XML, use Gradle. If the developer doesn't like to write code to do build, then go back to the XML. That's it.
Well, knowing your love of XML, I'm sure that you always use Maven, right?
It's funny though that you meant, because XML is like, considered old and busted, whatever. But as you're talking about the more declarative style of configuration now, it's kind of come back around to that. So it's funny. I'd be surprised if there's not like some YAML based configuration way for, you know what I mean, that compiles it to XML for you or something.
Oh, John. No, that's a bridge too far.
I can say that unfortunately there is a project out there called Polyglot Maven, which you can use YAML to define your POM file.
No, there's not. Nope.
So you mentioned Groovy and Kotlin, and I think part of the thing that I've heard about JVM that's interesting is that there's Java, but then you can run multiple different languages on the JVM. And that's something that, you technically can do in .NET, but you don't see it as much as I'd hope, but it's so, but like Kotlin and Groovy are both like, they're full for, like, my understanding is Android development is basically all on Kotlin now, right?
Mm-hmm.
No, not really. Kotlin wants to the teams behind the teams at Google and JetBrains that develop Android Studio and Kotlin. There is an intent of making Kotlin the default language of Android applications, but there's also Flutter and Dart and other languages. So that intent got fragmented with multiple choices now as well for Android, right? So Java remains the primary choice for the majority of Android developers. We can see that just by looking at Stack Overflow tags for Android. Um, but the interesting thing about Java, as you were saying, the JVM actually, for any developer who's not familiar with the JVM, but is familiar with WebAssembly these days, it's the same concept. You write some code, and then you write a compiler that translates that code into a bytecode, and then the JVM interprets the bytecode, just like WebAssembly. The main difference is that the JVM was invented in 1998, and WebAssembly was invented like 5 years ago or 7 years.
Yeah.
I don't know.
Now that's
same
all fair.
concept.
That's all fair, and that you took that in a different direction than what I was kind of thinking. So I'll concede that to you. However, that said, you did make one misstatement, which is interprets, because in the original or early stages of Java, everything was interpreted, therefore it was slow. But we have now just-in-time compilers, ahead-of-time compilers, and things that make it actually very competitive with native code, sometimes faster, sometimes a little slower. We have actually native code compilers now. So Java has, and I know that was just kind of just a conversational thing, but I want to make sure that we know it is not an interpreted language per se, in the same vein as things like Python. Although, again, I know exceptions even there. So it gets tough to talk about this stuff.
Yeah, we can say Java code. I'm a Java developer. I write some Java code. That code can either run in interpreted mode initially and then get native compilation with just-in-time compilation, or ahead of time, which is native all the way from the get-go. Actually, not really. Actually, it still compiles into bytecode, and then the bytecode compiles offline into native code, and then you run ahead of time. But those are the models. And for ahead of time, there is another project, and then we are just getting to the rabbit hole of the Java ecosystem, a project called GraalVM. So GraalVM is a project from Oracle that combines OpenJDK with a truffle framework that allows code to be compiled natively. And even the truffle, not truffle. Truffle is a framework that allows any language to run on GraalVM. Yes, so GraalVM is a virtual machine that is polyglot. The truffle framework allows that, and there is truffle for Ruby, for Python, for JavaScript, and then there is the native image program that compiles code into native, and GraalVM has that feature. So if I'm a Java developer, I can run Java code in several ways. And it's really about use case, understanding the scenario, understanding the needs of where this code will run, if it's in the phone or on the server, on the desktop, or on an embedded device, all sorts of targets. It really, yeah, it's confusing. I'm sorry, folks.
Well,
I'm sorry.
so that's interesting too, because like, the stigma of Java can be that it's big, slow, bloated, enterprise, whatever for big servers. But like you're saying, it runs on small devices, it runs on phones, it's all sorts of things. So you really do need to have a small, tight, battery efficient, all those sorts of things. And so, yeah, I don't, do you, and so that's something you basically are writing the same code, and then the compiler is kind of handling that depending on where you're deploying.
Yeah, I mean, the way the JVM works, the JVM there is a specification of the JVM on how the JVM needs to behave, but you can actually write a JVM in any language as long as you implement the instructions as per the specification. And there are JVMs that were developed for different kinds of hardware of different kinds of resources, embedded devices, mainframes, AIX, for example, right? Or Solaris. So all sorts of hardware got a JVM implementation with sometimes with different even instructions. So once you write that code, that Java code, according to the Java language specification, that code, once compiled, can run in any JVM that implements the JVM specification mapping out to that same version of the Java language specification. So that allows that a Java developer can write Java code for pretty much any kind and deploy in anywhere. Now, there's lots of gotchas and exceptions, and maybe this doesn't exactly work as you were thinking, but that is the principle, and it's been working quite well since the beginning of the technology.
Yeah, and just to add on to that a little bit, generally when we talk about Java developers or Java development and deployments, so the deployable artifact, typically you're talking about deploying using a Java virtual machine, a JVM, and that's where you sometimes get the whole, well, it's larger, it's a bigger footprint, it's slower startup, because when you start an application, it has to spin up that and warm up that JVM and execute the application. It does a bit of, again, that just-in-time compilation and kicks things off. So that's kind of the large majority of the use cases. When you want to build native code, that's maybe a small subset of all use cases. And the reason, because Java, well, again, excluding for the moment any mobile and Android, you've got a large preponderance of Java applications, which are enterprise applications. They are robust. They're always running. They're out there, servicing gazillions of requests every minute. And when it comes to applications like that, whether it takes 5 seconds to start up or 1 second to start up, it doesn't matter, because it's going to be running for days, weeks, whatever, and processing millions and millions of messages. And your big focus is not on the 4 seconds you could save on startup; it's on throughput, and it's on making sure that continues to run well and whatnot. So there are different use cases that necessitate different tools, but generally speaking, for that kind of the vast majority of use cases, you are talking about the standard JVM, which is fast on garbage collection, it's fast on response, and heavy on high on throughput.
Okay. Yeah, you mentioned garbage collection, and that's something too where people worry about that for performance. Is there anything kind of new on, like, when I follow .NET releases, they're working on things to do like multipass, or to like continue as over the what is it, PGO, or performance guided optimization, or things like that. Is there new stuff happening or happened recently on garbage collection performance?
Yeah, Oracle. Sorry,
Go ahead.
Want to go?
No,
Okay.
I was going to hit on the whole different in terms of different JDKs, because the community, well, I say community in general, but different builds, different approaches to garbage collection can be employed by different JDKs. So if you want to have very exceedingly low latency, maybe that won't be necessarily as efficient overall, but it keeps things moving along faster for things like stock trading and things like that. And you may have others that a little bit longer pause for an overall slightly higher level of efficiency might make more sense. So you have options in that regard. That was kind of all I was going to say, Bruno, if you want to take it from there. But that's, again, one of the strengths of various different builds of JDK. You can or you can choose which one suits your particular use case best.
Yeah, one of the interesting things that actually discussed this recently, the JVM specification doesn't say anything about garbage collection. It's one of the interesting things that people think, oh, this JVM must have this garbage collector. Actually, no, it must run the Java code. Garbage collection is not part of the specification,
Wow.
which means you can implement a JVM and not collect anything. And not only that, there is actually a garbage collector that Red Hat wrote that does exactly that. It's a garbage collector that doesn't collect anything. It's only for it's mostly for testing purposes.
Okay.
But there are multiple garbage collectors in the Java ecosystem. That's the reality. In the OpenJDK project itself, there are 5 or 6 garbage collectors that you can choose from. OpenJ9 is a different implementation of the Java virtual machine specification done by IBM and the Eclipse Foundation, and also they have their own garbage collection implementation or multiple implementations. Azure Systems has a garbage collector called Zing, also a different implementation, and I think that's that is technically a commercial product that they license to you. But at the end of the day, there are multiple choices, and customers and developers do need to understand if they want to go down that path of performance tuning, they have to understand how the garbage collector works, how their workload is behaving, and what are their requirements in terms of like business needs and SLAs to make the right choice and the right tuning for their application. So this takes us back to the question like, is Java slow? Well, it can be if you don't do the right thing, right?
Yeah.
But it can be super fast once you have those understandings, and it can be extremely fast.
What you mentioned earlier, some of the Microsoft and Azure support. Like, what is the Azure? Are people running Java workloads like containerized, or what's kind of the main thing that you see people doing?
Mark, you want to say?
Is there like a
Okay, go ahead.
standard kind of, like you mentioned some of these big, like LinkedIn and like large applications? Is it pretty standard now to be running those containerized, or?
I mean, we have different ways you can do that, and of course, I suppose like Java developers and environments are all different use cases, needs, desires. But you can containerize them. You can deploy from code into containers, VMs. You can run in a managed platform, something like Azure Spring Cloud. So you have a lot of different ways to get there, I guess, is for lack of a better way to put it. And everybody seems to, depending on where they are in their journey. I hate to put it that way because it sounds almost like where you are isn't the final endpoint, and maybe it is. And there are people who are maybe where they want to be, and for the next for the foreseeable future. But if you are embracing moving things to Azure, let's say, and you have a significant kind of center of gravity in house or a private cloud, whatever, you're probably going to try to mirror your existing setup, and that may involve VMs, and that's fine. We fully support that, but we also have the ability to containerize to use something like app service. Bruno, what am I missing? I mean, the upshot, I guess, is that we meet you where you are, and we offer options for where you may want to go.
Yeah, once an application is containerized, developers can deploy that container to 5 services on Azure. Actually, 6, depending on the application. So the application is a container, Azure VMs, Azure Kubernetes Service, Azure Container Apps, Azure App Service, Azure Spring Cloud, 5. And actually 6, because if it's a function designed application, you can actually also deploy to Azure Functions. So there is a huge interest in containerizing applications. So you have that flexibility. Where do you want to put and take advantage of the services that your business may need? But from the developer standpoint, it's still just a container, an application inside a container, and that gives that flexibility of deployment models. Now,
oh, go ahead. Sorry, I thought you were.
Yeah. Now, just putting a Java application inside a container it sounds simple at the beginning, but it can be very tricky once you go to production. But I will pause there. What's up, Mark?
Well, no, I was going to say, because both of us have kind of failed to mention that we actually do have partnering agreements with companies who offer application servers. So we fully embrace and support that as a destination for Java applications as well. If you're using something like Java E, Jakarta E, in terms of enterprise Java, obviously if you're using Spring Boot applications, it's a little different or significantly different story, which is kind of where we've spoken to up to now. But we also support things like JBoss EAP, WebSphere, WebLogic, and things like that. So if you're coming from that kind of an environment, we have a home for that as well.
Yeah, and I did forget to mention Azure Red Hat OpenShift, which is another service also for containers. So when so speaking a little bit more about containers and Java, and we have documentation coming soon. I don't know when this blog is going to be live. This podcast will be live. If you're watching this, check our documentation, or listening to this, check our documentation. Maybe this is already published. But we have documentation about how to containerize Java applications and the things that you should watch out for, especially in terms of memory constraints and CPU constraints that are applied to the container and how that impacts the performance of the JVM.
especially if you're using an older version of Java. Just I'll leave.
Especially that.
Yeah, I'll leave that out there. Obviously everybody wants to be on the latest greatest. Everybody should be on the latest greatest, but there are a lot of times constraints that keep folks from again, if they're migrating something that may be an older, steady, reliable application, it may be still using Java 8, but it's so considerations are different as you advance because Java is advancing and getting better and better about that, as you might imagine. So
Yeah.
You mentioned application servers. What's an application server? What do I need it for?
I can. So I worked at work when I was one of the outbound PMs for WebLogic. Uh, an application server is actually very much like Kubernetes, but in a way that only talks Java. It's not polyglot, right? But at least not polyglot in terms of language. If it's a Java JVM-based language like Scala, Clojure, or Kotlin, still works. But it's a Java-based runtime. But an application server has capabilities like deploying multiple applications, having a cluster with lots of nodes, managing resources, managing connections with databases and messaging systems and identity systems, all of that, so that these applications, once they are deployed, they may have access to these resources more easily. And the application server manages these resources for the applications. It's not necessarily the application managing those resources. And that is what made the application server model very broadly adopted back in the days, because it was very good and still is a very good model for many customers that are not seeing themselves with this need. I want to go Kubernetes, I want to go containers. Some customers don't have that. It's not like a must do. You got to have the business need. So that's why we have these partnerships with IBM and Oracle to bring this, and Red Hat, to bring these traditional application servers to Azure as a managed offering, so they can lift and shift, as executives like to say in marketing, lift and shift applications to the cloud more easily.
Yeah, I mean it's one mechanism for deployment, right? So you have people who love it, you have people who hate it, sort of like the Maven and Gradle thing, really. Oh, go ahead, Bruno.
Yeah, there's a new project called Dapper that is a you develop a microservice, and with Dapper, if your microservice needs to talk to a database, it actually talks to a sidecar of Dapper, and then Dapper does the communication with the database. That model is what application servers are.
Okay.
But Dapper happens to be the sidecar of Dapper, happens to be a component inside the application server, and the application server happens to be Kubernetes at the end of the day.
Okay. So you mentioned things like deployment and management of your application. Like I'm thinking of deploying updates and specifically this kind of brings to mind for me like Log4j. Like recently, there are a lot of people needing to kind of patch and maintain an update. What is the I don't know, like what is the approach for managing and maintaining, and what was the impact for things that you folks saw with like Log4j and needing to make these updates?
So funny enough, the Log4j issue was so basic. It was not even necessarily a security vulnerability per se, not a bug. Actually, it was a security vulnerability, but it was not a bug. It was actually a feature by design that was being abused by cyber attack, right? So because of that, it was actually pretty simple to update Java applications, or even just secure the feature without even updating the library version. And when it comes to the Java ecosystem in general, that happens. It did happen pretty fast, the resolution of the problem. But now you're looking at a very long tail of people that are not completely aware. And Sonatype, who manages the Maven Central, they have a dashboard that shows number of downloads per log4j version. And
Yeah.
affected versions are still being downloaded too much. The number of downloads of insecure log4j versions is still damn high.
Yeah.
Now, I will say this, because I'm more from the Spring side of the Java ecosystem, and Spring's default is logback. So unless you specifically overwrite it to use log4j, this was not largely a non-event. So that, obviously we have good partnership and Azure Spring Cloud, and we're a great destination for Spring applications, and that was almost a non-issue for a good chunk of the Java applications that we host and manage here because of that. It just wasn't. It's something everybody was very aware of and wanted to make sure that we were all safe and everybody's happy and all that. But in many cases, it just wasn't an issue at all.
Okay.
Yeah. Yeah.
I wasn't aware of the Azure Spring Cloud. That's pretty cool. I've heard about Spring Boot generally. Like there's a .NET project to implement a lot of like interop stuff with Spring. So I'm familiar just from that point of view. But I hear a lot about Spring Boot just kind of in general. Is that still pretty active? And
oh gosh, yes. I don't want to push too hard on this because obviously lots of choices in the ecosystem, which is a good thing. But Spring Boot is wildly popular. Spring in general, Spring technologies. You have Spring Data, Spring Security, and a lot of different Spring projects. And over half of all Java developers, enterprise Java developers, use some or many parts of the Spring ecosystem. So yeah, it's rather huge, and we at Microsoft should be very proud because we work really well with the Spring team. First with Pivotal, and then with VMware when Pivotal and VMware came together. So yeah, we offer Azure Spring Cloud is something that nobody else can really. There's no parallel outside of our world. It's a jointly developed, jointly supported, and it's just kind of that natural home for Spring applications. So yeah, it's kind of a great success story for both companies and that giant ecosystem that are Spring developers and Spring applications.
Okay. Going in a totally different direction, way back when I first looked at Java and work with Java was actually desktop applications. And that was a thing, early on, it was like, hey, we're going to have cross-platform desktop apps. And I haven't really now it's all basically you see Electron and, you don't see Java desktop apps. I randomly, I did looking and loading plugins and stuff, I saw Java FX listed. What's kind of the current state of Java for client and desktop application development?
Well, I'll start off on this, Bruno, and then you can correct me where I go off the rails here.
Yeah.
But again, I think everything has shifted to not everything. Many things have shifted to the browser and extensions of said construct. But there are still some things. I know Bruno and I both know folks who work with NASA and with trading companies where you have desktop type of applications or desktop applications, I should say, in some capacity. That it's very important to have that raw processing power, to have the full control over the rendering that you just can't match still. Unless you do a desktop type of application. So Java FX, it certainly doesn't have a massive market share, but it has a very strong vocal and an important niche that it fills.
Yeah, not only Java FX, but Swing is still a critical component for
True.
Java graphical development. There is a software, a commercial software called Spine, and it's a 2D animation editor. And when you look at the interface, you don't tell it's Java, but it's actually a Java-based application. When you I think I'm not sure which bank or financial corporation in Canada they do have a trading app that is written in Java as well. So you go to their website, you download. It's a Java app. It comes with the JVM. Minecraft Java Edition is used by millions of gamers in the world, and it's a Java desktop application. and actually 3D Java-based application, just to make sure that people are aware of that. And as Mark said, in the trading and finance industry, in manufacturing, uh, government agencies in general, we do see that number of Java desktop applications. They just don't happen to be something that you download for your parents at home or your brothers and sisters in school. It's something that employees actually end up using, or researchers in the academic world end up using. NASA has lots of tools internally that are written in Java, but you don't see those published in the App Store because they are internal use, right? And I can say there is a big movement even for indie gamers, indie games that are using a library called LWXJGL, something like that. It's a lightweight LWJGL, lightweight graphical library for Java. Uh, and it's used for games. There are some games that are published on Steam platform that are written in Java with in combination with that library to use uh, OpenGL. So so there is a market for graphical Java applications. There are great software libraries and tools to do that, but it's not where startups and uh, companies are doing cloud development. I mean, if it's a cloud development, it's going to end up in the browser, right?
Yeah.
But there is. If the question is there? Yeah, there is.
Okay. Um, you had mentioned earlier big data and like Apache Spark and that sort of thing, and so that is a big area of Java development, right? That's including, you
Yeah,
said, at Microsoft.
yeah. Big data is a big deal for Java because Java is one of the very few runtimes that is super easy to write an application that will consume a huge amount of data, and the JVM will manage that data in memory for you. You don't have to write code to deal with that. The JVM
Uh,
will deal with that for you. And actually, the garbage collector will deal that for you. Uh, Oracle and Red Hat are working with two garbage collectors that can handle very massive heap sizes of object allocation in memory. Uh, Oracle has one collector called ZGC, and Z stands for near zero latency, near zero pause time of the collection. Um, and and they did publish a benchmark recently in Java 17 where ZGC running on a machine with a heap size of 128 gigabytes of RAM. That's the amount of memory reserved for object allocation. They had pause times of less than 1 millisecond. So
wow. Okay.
so imagine like real time data, big data, and you need your application to not pause, right? So ZGC achieved that. Red Hat has another garbage collector called Shenandoah, and it comes with similar capabilities and near real time uh, 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 flow execution. So, so those are impressive numbers when we think about the business needs of different companies, especially the world of machine learning
Mm.
and AI. You need to process that data, and Java systems end up being a great option because you just need to write the code that will compare the data, to process the data, but you don't have to manage the memory or manage cleanup and all of that you would have to write in C++ or other languages. And there's a lot of projects that are already implemented in Java, so you don't have to rewrite anything as well, right? So you just use Kafka, you just use Hadoop and Spark and Apache Pinot and several other projects that have been written quite a while, and they only benefit from newer versions of Java that get more performance improvements. So it's the same code running on a
Mm.
newer version of the JVM with better performance. You don't have to rewrite the code. You don't have to recompile the code. You just need to deploy that same code already compiled on a new version of the JVM, and you get better performance.
Okay. One more question as we get close to wrapping up here. What's new with the Java language itself? Is there much going on with that?
Yes, there is. And I was talking to Mark before this, and Mark said, "Oh, I want to talk about field classes. I want to talk about sealed classes." Please go ahead, Mark. Talk about sealed classes.
Well, that wasn't exactly what I said, okay? And let me set this up a little bit, because in the old days and prior to what I want to say like 3 years ago now, probably a little longer than that now, because time is kind of fluid over the last couple of years. But in the old days of Java, typically it was several years between releases. So you had these big dropped releases, which had a lot of, well, potentially had a lot of changes, and then you waited, and you waited a long time, and you had different patches and updates that came out throughout several years after that. A few years ago, we went to a 6-month release cycle with Java, which sounds insane when you're coming from a 3 to 4 year, Bruno. I'm going based on just off the top of my head, release cycle. So 6 months, that's crazy. What can we get in there? But what it actually has done is allow us to, I say us, I mean, it allows the JVM designers and maintainers to go ahead and drop things in for kind of preview type of functionality. So you have long-term supported releases, and then you have in between those every 6 months, you have these kind of interim releases, if you will. So Java 17 is now out, but Java 16 was 6 months before Java 17 rolled out. Java 18 will be 6 months after that. 18 will not be a long-term supported release, but we'll have a few new things in there. And it allows you to iterate, get feedback, and kind of hone things before they become production features. So with Java 17, I was telling Bruno that, and to be very specific, the big things that I kind of honed in on were the sealed classes and the better pattern matching in terms of the switch statement. So some of these things, when they hit production, if you will, aren't huge features, but they are huge time savers. They kind of, the fact that they're small but incredibly useful are something that you wind up using over and over and over again, versus like the graphics stuff for Mac. I mean, that may be something that it'll be nice, but it's not something I will go, wow, that's an upgradable thing, but something I'll use every day for every application I write. That's small feature, huge impact. So with sealed classes, you can define the ability, or define a class and a set of child classes, and that's it. You can't extend that any further than what you've already defined the ability to do so upfront. And of course, better switch statements where you can do pattern matching on that, and more. It leads to more concise code. It's small, it's compact, but it's very easily readable in terms of the choices that are available to you when you're evaluating something. So those are, I think, those are the things that kind of bubbled at the top of my head with Java 17, because I see them having an outsized impact just because they'll be so commonly used.
Yeah, there are a few more things. One is something called helpful new pointer exception. Any experienced Java developer will be like saying thank you whoever had this idea and wrote this
That is
code,
true.
because when you have chained calls like A.B.C, and you call different methods and attributes, and then you have so many chains that there's a null pointer exception on that line, you don't know which part of the chain is null. So this contribution is actually written by SAP. SAP is a contributor of OpenJDK, and they also built their own OpenJDK binary, and they wrote this feature and upstream to the project. So now, if there is a null pointer exception or a null value in that chain, the message will say, this is the part of your statement that is actually null. And everybody was like, oh my God, just saved my day. Nice. Another interesting feature is records. Records have been in development for a few releases already, but it became final GA on Java 17. And with records, you can basically define a POJ, or plain old Java object, or a record, a class that will hold some attributes, and you don't have to write get and sat and equals and hash code and toString. All of that will be generated by the compiler. You just say public record and then the attributes that you want: string name, integer, age, and that's it. And everything will be generated by the compiler for you.
Nice.
There is another one interesting. It's called text blocks, multi-line text blocks. Uh, my very first application was actually to generate some HTML code, and I can tell you that was not pleasant because you have to break down the string and plus signs, concatenate the strings every line. It's super annoying. But then it's actually even bad for database applications where you have to write SQL queries, right? And you have to break that down in multiple lines. That's super annoying. So now you actually have like 3 quotes, and then you write your text in multi-line, and then you close it with 3 quotes, and that is the support. What else we got here? I have a cheat sheet that I'm looking at.
In fairness, while you're looking up the next thing, some of these things have been in previous releases, but this is the first long-term supported release, Java 17, which rolls them all up together, which is so this will have the higher adoption. This will have the higher impact just because people working in a large corporate environment or a government or whatever, they're not going to go to the 6-month release cycles in many cases because they're going to wait for that LTS release to make that transition. So the even though some of these things have been incorporated in earlier versions, this is the money release, I guess you'd say. So
yeah. Cool. Yeah, there are two. I mean, there's a bunch of APIs that changed. There's a website, Java Almanac, that shows all the API changes between versions. And but there are two that gets everyone's eyes. One, there is now an actual HTTP client API that is part of the Java platform. So if you want to call an HTTP endpoint, a REST endpoint, Java has that API already implemented in its default APIs. And the other one, which is funny, it took this long, but now we have a class that helps you format hexadecimal to and from hexadecimal. But it's there finally.
Yeah. Well, it is nice to see, like, and going back to what you were mentioning, Mark, but just these quality of life things, where it's like you just some things, like I'll see with .NET, it's like, okay, you're finally adding this. Well, I'm still happy to have it, But.
Yeah,
it's weird. I always feel weird when I say something that just is really a minor thing, but you're like, this is amazing, and people are like, are you out of your mind? No, because I can see a bigger impact, even though it's a small impact. If you multiply that by 1 million, it's huge. Then as the old joke goes about, 1 million here, 1 million there. Pretty soon you're talking real money. I think some politicians said that. Talking about it like a government budget or something, but the same thing. If you have a very small feature that is immensely useful in everything you write, it just has an outsized impact. So the other stuff is really cool and really amazing in certain contexts for the people who need it, but for almost every application, there are going to be little things that touch all these apps. That's what I get excited about. So
cool. All right. Well, I think we're at a good spot to wrap up. Is there anything big that I forgot to ask about or we didn't touch on?
I'm pretty happy. Like, this is a great opportunity to share a little bit about the Java ecosystem with you and the folks that listen to you. I mean, from Microsoft, what I can say is Java learns from .NET, .NET learns from Java. All these programming languages at the end of the day are ways of connecting people, but also tools that enable these people to develop nice things. And if ideas here can go there and make everybody happy, everybody benefits from. So we are in a good shape with the stories of Java and .NET and JavaScript and Kotlin and Clojure and Scala and Ruby and Python and PHP.
There was a little pause before PHP, but yeah, like over time, it's like earlier on in my career, it's everyone wants to battle it out and my language is the best or whatever. And it's kind of nice to be at a spot now where it's like you said, we learn from each other. There are more tools, especially as things are like containerized, or like you can interop back and forth, and so it's fine. It's not strange to have, like, I was working in an application recently and it had Kubernetes going. It had several Java Docker instances, and so like in .NET, and they're just REST calls back and forth, and it's all we're all playing nicely together. So
yeah, there is another about time. There is another topic, definitely for another podcast, another session. But I feel we are not in the debate of languages versus languages now. I think it's more runtimes versus runtimes, and trying to identify this runtime is better for this use case, that runtime is better for that use case. Because language, at the end of the day, gets compiled to something that will be interpreted or natively compiled later. And we saw this with GraalVM, F# and C#, JavaScript and TypeScript, Clojure and Scala and Kotlin and Gradle and Java. Lots of languages, but the number of runtimes is actually a lot smaller. So I think we should consider starting comparing runtimes in terms of like use cases instead of languages. I think languages is important because you're a developer, you have to write on something, right? But when the application actually goes out, what matters? Is it the language or the runtime for the use case? And there are use cases for all runtimes.
Yeah. Well, I like the way you say that too, because it's not which is the best, it's which is the best for a use case, or which is, and you can build anything in any language, it's just you're going to have a better time, or it's going to run a little faster or whatever. And,
Yeah. And you know what they say, if it can be written in JavaScript, it will be written in JavaScript.
There you go. All right.
And
well, that's a great place to wrap up. Thank you, both of you,